Hello everyone, welcome back to the second part of the module 6 of our AI engineering crash course. Today we'll talk about fine-tuning and hosting open source models. So in the last video, we just gave a broad introduction of Hugging Face, the tool and libraries that you have with Hugging Face, and the models that you can find on Hugging Face. So now I'll talk about how to fine-tune these models and host them with a specific provider. Okay, get started. So what does fine-tuning actually means? So let's say you have a model, like you have nothing at the beginning. You have a deep learning algorithm like this. You feed a lot of data to the deep learning algorithm, just random data, right? A lot of data. And what you get back is a model. This model is good at everything that we've given in the data set, okay? So let's say your model is actually everything over the internet. So the end model that's go from this model, from this training to this is called a pre-trained model. So this pre-trained model can be used, but in general, it's really bad at specific tasks, but really good at generic tasks. Okay. It's like GPT-3, not ChatGPT, but GPT-3.5 or GPT-2 or just simple completion models. So they are trained with on a lot of text and they know how to complete text. So now when you need a specific use case or you want this model to be good at one thing, let's say code generation, for example, you now need to take this base, feed it a lot of code. Okay, let's say you have codes here. You pass the code to the model. To this pre-trained model. Let's put some different color here. And the result will be a specific model that's extremely good at coding. Okay. So let's say this is the red model. And this red model is really good at coding. Okay, so the process of fine-tuning actually helps you make one of the generic model really good at what you have to perform as a task. Let's say you are in a company and your main task in this company is actually building a marketing platform or marketing tool, and you want to use an AI to be able to out to do automatic outreach and many other things. If you try to use normal, simple pre-trained models, you will have generic text, generate emails, everything will be really bad. And if you want to train or to make this model generate emails exactly as you do internally, you need to collect a lot of data, a lot of emails in a specific format. I will come to that a bit later. Train the model with it, and then we'll get a model that can actually mimic your tone or mimic your way of writing emails. Okay. But what I need to mention here is that feeding data to the model doesn't make it accurate. Not at all. It makes it good at mimicking the way you do things, but not understanding the knowledge from your data set and giving it back. So to have a model that do not hallucinate, you still need retrieval augmented generation, and you can find a video about it in the playlist in the description below. So here with the coding model, now you can integrate it into any app. It's actually same. It's actually the same model, just that you have two ways of actually training this model to get this. The first thing is to just get the parameter, the end weight of this model, and get it as a starting point to train your end model. The second is to freeze some layers of the big model and then train the remaining layers. So these are just generate concept. You can find a bit more information about this on Hugging Face, and I will put some resource in the description as well. But in general, you create a specific kind of data set with a specific format that's adapted to the pre-trained model. You feed it to the pre-trained model and you get a specific model at the end, right? Now let's do this practically. I will say this is one of the best notebook to show you how to do that. I think the company Breath.dev have been bought by NVIDIA, but the company were actually just giving you GPU to train and work with notebooks and maybe fine tune your models and everything around it. So now when you type Breath.dev, it will get you back to NVIDIA, and you can actually rent GPU for a specific amount of time and run your Jupyter notebook on it to fine tune specific models or things like that. Okay, so this is made for Mistral, and yeah, it's still valid for many other LLM out there because they basically have the same structure most of the time. So here, the first thing is to have the data in the specific format. You can have this fine-tuning part done by, hosting platform without having to go through all the code that you will see here. But if you want to, you can still go through the code, install the packages, load the data set, instantiate the accelerator. This is not really important unless you want to use weight and bias. This is just for using it later for inference or for testing. Loading the Mistral model here, and then here loading our tokenizer. This tokenizer also comes from Hugging Face. I think I talked about token in the introduction of the course, so you can go back there and learn a bit more about it. Here you just need to plot. It's just simple to plot the distribution of your data, of the inputs. Here generating tokenized prompt. So you have the tokenizer here. You get a tokenizer and you generate and tokenize prompt. Okay, this is to generate and tokenize a prompt. So you can go through this. I will put it in the description, and I will show you where you are doing the fine tuning and where you are actually loading QLoRa and parameters and doing the fine tuning. Okay, you can see it here. LoRa, you have this air here. That's some parameter from the QLoRa paper. You can also go in the paper and understand a bit more what happens here. But to be honest, I think from the paper they said it did not influence the result that much to have a really small or really large value here. So yes, this will help your computer support the fine tuning. Okay, so this will make sure that the big model is broken down into some kind of structure that your small computer can use or some other computer can easily use to work with to fine tune your initial model. So you just pass the model and the configuration for LoRa, and then you have the model here with the pre-train. You can print the trainable parameters, and you will see that some layers are actually frozen and some other layers are trainable. Okay, and then after that you can just run the training. Prepare model, and then you'll have here trainer.train coming from Hugging Face as well. Most of these parameters are actually from Hugging Face. Is from some other trainer specifying other parameters that you need for fine tuning, and then the training part. This will fine tune the model for you, and then you can save the model. You can save it in a specific checkpoint and use it later for inference. Okay, so you have some tests at the end. I'll put this in the description, but I will also show you the easy way to do this. Okay, the easiest way to do this is to go to a model, like to a platform like maybe Replicate. If you want a specific kind of model, you go to Replicate. Okay, Replicate like this. So, okay, let's click on explore here. Most of the time you have visual models, simple model, just any kind of model here. If you look maybe for, let's say, stability or stable diffusion, you'll find it here, and you can actually run it with this API and also fine tune it on the platform. Same for platforms like Fireworks or Together. I think Together gives you also a simple way of fine-tuning models and hosting them. You can actually come down there and see the pricing. Normally you'll see the pricing somewhere here. Where is it again? Yeah, somehow while working with this, you will see the pricing, and you can actually compare the pricing that you get from here. You have it here running 0.034 for stability. With Together, it's the same thing. When you create an account, I think I show you how to do that in one of the videos. You can actually go to the documentation and look for, where is it again? Search for fine tuning. And you will see how easy it is to do fine tuning here. So you prepare your dataset in this specific format, not the format that I showed before, still in JSON-L, but the format is this one now. Okay. And then you upload the file, same thing you will do with OpenAI, and then you run the fine-tuning job. Okay. And then yeah, it's fine-tune the model for you directly, and you can use the fine-tune model later. Um, so if you don't want to go through all this training and all these phases here, you can just directly fine tune it on a platform like Together. Talking about open source models, the models, of course, and host it also on Together. I think we went through it as well. I showed you how to use this in your app directly. So I'll put the link in the description as well, so you can go through it again. But yeah, you have this platform where you can actually go from a pre-trained model to a fine-tuned model in few seconds, or with just on some sample code. And at the end, if you want to run this notebook, you can rent a space at on NVIDIA and run your notebook there, upload your data set, and also make sure to put checkpoints and download these checkpoints, because when I was using Breath.dev, sometimes it just delayed your data. So I hope it's changing now that NVIDIA is managing the platform. But in general, yeah, so that's how you steer an open source model um, to do things that you want to do. But same with OpenAI. So if you wanna, if you want ChatGPT to do to be extremely good at your task, you can either use model distillation, that you can also do here, which means extracting data from large language models like O3, like a bigger model like O3, and actually create this kind of data set with it, and then fine tune the small model with that as well. Yeah, so with that said, I hope the introduction to fine tuning and hosting models were actually good enough for you. If you really need more details, go to the Together, Firework, Open Router, Replicate section of this course, and you will understand a bit more about these platforms and how you can use them to host your model and how you can run them into your Python code. So thank you for watching, and see you in the next part, in the next module, where we'll be talking about image generation models.